Hi guys, welcome to the Junior Astrophysicist, and in this video we're going to be looking at Schrodinger equation and interpretation of the wave function. So let's begin with this video. So this is today's topic, Schrodinger's equation and the wave function. Let's begin. Now, let's just have a simple look at the Schrodinger equation before we get into detail. Now, this is the Schrodinger equation. So firstly, in today's video, we're not going to be discussing anything about the symbols, the mathematical functions, nothing. We're just going to understand about the result of the Schrodinger equation, what you get, and how do you use it. That's it. That's all we're going to see in today's video. Now, let's see the first point. When the Schrodinger equation is solved, the energy of the electron can be obtained. Now, that's what the Schrodinger equation is used for. Now, in this equation, you can see in the end that there's an E and a symbol. Okay, I don't want to get into that symbol now. We'll just focus on the E. E states the energy the electron can have because Schrodinger equation is around electrons. We're supposed to be finding the position of an electron. So with that, you can find the energy of an electron, and using the energy of the electron, you can determine its energy level or the orbital shell it is present in the atom. So right now using this equation, we can measure its energy level, like its position inside the atom. But we should also know where it's inside that energy level. We should know a very specified position. So we'll get into that part soon in this video. Okay? Now, the first part of the equation is the kinetic energy of the electron, and the second half is the potential energy. So usually when you have the energy of any object or body, you have the kinetic energy added with potential energy, and then you have the net energy or the total energy. So it's the same thing over here. So the first part of the equation is the kinetic energy. The second part is the potential energy, and when you add these up, you get the total energy with which you can determine its energy level. So yeah, you can see the equation right now over there. So the first part is the kinetic energy, and the potential energy, and the total energy. Now, this is a simple structure of an atom. So we have the nucleus in the center, which contains the protons and the neutrons. The first shell, or the energy level 1, and then the energy level 2, and then the energy level 3. So now, using the Schrodinger equation, I can determine in which energy level the electron is present. Now, using the wave function, I can determine on which part of the energy level is present. So let's look at it soon. So as the energy level is found, using the wave function, we can predict its position in the energy level. The solution to the Schrodinger equation also gives us the wave function. The wave function is represented by the Greek symbol psi. Okay, so we usually have the wave function as a wave graph or a curve graph. In that kind of graph, the x-axis denotes the spatial position or the possible positions of where the electron can be. So if we have a shell like this, there are possibilities of having the electron either in this point or this point or this point or this point. Now, while we're trying to find the exact point, we can have a probability graph. What's a probability graph? It has curves of all positions, all possible positions. And so you have one graph, like one curve for this point, another curve for this point, another curve for this point, and the final curve for this point. Now let's look at the y-axis. So the y-axis determines the wave function. So using that, using the wave function, you can say that the curve which has the highest probability intensity or the highest amplitude, we have a higher chance of finding the electron at that spatial position. And where there's zero amplitude, there's a 0% chance of finding the electron up there. So solving the position of the electron. Now, if you square the wave function, you would get the position of an electron or the most possible position of the electron. The value should be squared. You should not just not square it, or you'll be getting a negative mark. So this is a simple diagram of the curve. And with this, you can determine its possible position of the electron. So the x-axis shows the spatial position, and the y-axis shows you the wave function. Now we have three curves in this. So while looking at the three curves, you can understand that the third curve has the highest amplitude. So there's a high chance of finding the electron in the spatial position of the third curve. And the point, if like you have certain points, like if the third curve is at point 5, depending on the way you label your y-axis, if you've labeled it somewhere and your third curve has an amplitude of 5 or 10, you square that value and you're gonna have you'll get a chance of finding the electron. So this is the interpretation of the wave function. In the previous diagram, the third curve has the highest probability intensity. So in the spatial position at which the third curve is present, we have a high chance of finding the electron. We won't be able to find the exact position of the electron, but can get an approximate value. So the reason we can't find the exact position of the electron is because we don't have an exact curve. It's only like you have a probability. Drop a like, share, and subscribe to the Junior Astrophysicist. So have fun learning. Bye guys. See ya.